Time is not absolute. It's not some universal clock ticking away at a consistent rate, independent of the spatial world. No, the passage of time depends on your perspective. Let's see how this works with a race in space.
The race begins at the
Interstellar Lighthouse.
You immediately blast off at 1/3 the speed of light, and your much cooler friend Chad shoots off at 2/3 the speed of light. Of course, you're no match for a photon coming from the lighthouse, which actually travels at light speed. The paths of each object can be drawn on a space-time diagram, with the vertical axis showing the amount of time since the race began, in seconds, and the horizontal axis showing distance from the starting point, in light seconds. Since the lighthouse stays at the same position in space as time passes, its path through space-time is a vertical line. Your path, on the other hand, will have a slope of 3, because you're traveling at 1/3 the speed of light. Chad's path will have a slope of 3/2, and the photon's path will have a slope of 1. These paths on space-time diagrams are called world lines.
Now this is just the perspective of someone sitting at the lighthouse. What do things look like from your perspective? Well, we need to keep 3 things in mind.
1. The observer's world line always coincides with the time axis. From your perspective, you aren't the one moving. Instead, everything in the universe is moving past you. 2. The angle between the old observer's world line and the new observer's world line remains the same. If someone at the lighthouse sees you moving forward at 1/3 the speed of light, from your perspective, they're moving backward at that same speed. 3. The speed of light is constant. Since our space-time diagram shows light speed with a slope of 1 or -1, any line with a slope of 1 or -1 has to remain unchanged.
Enter Lorentz Transformations, which transform world lines from one perspective to another.
Let's look at a Lorentz transformation from the lighthouse's perspective to your perspective. Your world line now coincides with the time axis, the angle between the red and blue lines remains the same, and the speed of light remains unchanged.
Lorentz transformations show us that observers moving at different velocities perceive time differently.
If an asteroid collision occurs, say, 5 seconds after the race begins and 4 light seconds in front of the lighthouse, it won't occur at the same time for you, and it definitely won't occur at the same time for Chad. What if there were 2 asteroid collisions? Even the amount of time between each collision would be different for you and Chad, because time is literally moving at a different rate relative to each perspective. In fact, the sequence of events is also relative. If 2 collisions happen on either side of the lighthouse at the exact same time, the moment the race begins, from your perspective, the one in front of the lighthouse will happen first. And if you had been moving in the opposite direction, you would have seen the other collision happen first.
As you can see, the cosmic clock of the universe is not as consistent and linear as we might think. As Einstein once said, the distinction between the past, present, and future is only a stubbornly persistent illusion.